Way back in stage 2, we introduced the idea of arrays. Up to now, they've all been one-dimensional. They have length, but they don't have width. But sometimes we need arrays with more dimensions. While this video covers 2 dimensions, the idea generalizes to any number of dimensions you want to store. When we create a one-dimensional array, the declaration contains one pair of square brackets, and the new statement specifies the length of that array, the size of its one dimension. Two-dimensional arrays need 2 pairs of square brackets and the size of 2 dimensions. The first dimension is the number of rows in the array, and the second is the number of columns. For example, suppose we wanted to keep track of the average temperature in each season for 3 locations. Then we'd use a row for each location, and that row would contain 4 columns, 1 for each season. So there is one index for each dimension of our array. When we want to access a particular entry, we have to specify which row and which column in that order. So in our weather example, if our location number 1 had an average winter temperature of 15, we'd use index 1 for the location and 3 for the season to store that temperature. Notice that row is always the first index and column is always the second index. When we use two-dimensional arrays, it feels like they make a grid, but they are really stored as an array that points to the arrays for each of the rows. So when we index by 1 and 3, the 1 picks which row we're going to use by indexing the first array, and then the 3 indexes that row to get to the right place in our grid. So let's look at that in Eclipse. I have stopped at this breakpoint, and you can see I declared the array of our temperatures just like we have in the slides, and I have set the winter temperature for location 1 to be 15. If I look over here, so I'm stopped at this breakpoint. If I look over here, when I first open Y, you can see it is an array of 3 things. That is the array that is pointing to the 3 rows. And then if I open location 1's row, then you see just the data that is in that 1 row of the array. We can use the fact that our array is stored this way to see how many rows and columns it has. Remember that we can use .length to get the length of any array. When we do that to our 2D array variable, it will look at the first array, the one that has an entry for each row. So the length of that is the number of rows in our grid. We can index our array by a row number to get one of the row arrays. The length of that will give us the number of columns in our grid. Because Java stores 2D arrays as an array of arrays, our grid doesn't have to be rectangular. We can make a 2D array where every row has a different length. This is called a jagged array. Everything works exactly the same way. 2 index values that are the row and the column that we're interested in. The length of the variable gives us the length of the first array, which is still the number of rows. We can index the array by a row number, and then the length of that will be the number of spaces in that row. There are 2 ways to create a jagged array. If we have values that we want to fill in, we can use an array initializer. The innermost curly brackets contain each row's data, and the outer curly brackets hold them together. If you don't have the values, you can build each of the arrays by hand and then connect them by putting a reference to each row into the high-level array. When we started working with one-dimensional arrays, we talked about how to walk through an array, how to look at every position of the array. Remember that the standard walking through the array loop is a for loop. We can do the same thing to one row of our two-dimensional array. Suppose we wanted to sum up the values of a particular row in the table. This loop is going to use the variable call to walk through the array y sub row. For example, if row is 2, then we're going to be walking through this array. y sub row dot length will be 5, so col will go from 0 to 4. Y sub row sub column will walk down this array. So our usual walking through the array loop structure works to walk through one row of our array. If we want to walk through the entire array, that means we want to walk through row 0, then row 1, then row 2, and so on. That's just a loop that is walking through the high-level array of row pointers. So this inner loop is exactly the loop from the prior slide that is walking down one row. This outer loop is making the variable row start at 0 and go through the rows in order. Together, these will walk through the entire array. Note that the example here is a jagged array, but this code would also work for a rectangular array as well. Sometimes we want to walk down one column of a 2D array. For our weather example, if I wanted the average temperature in the summer, then I would need to sum the values in the summer column. We can walk down a column by holding the column index constant. Here, I've made it be 1. Then, we use a loop that walks through the rows. So we're indexing by row and column. That will walk down one column of the array. Now we have seen two-dimensional arrays. We know how to create them, how to index them, and how to walk through them, whether they are rectangular, all rows having the same length, or jagged, having rows of different lengths.